close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. See the horizon, turn us to thousands, and we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. Yeah. We are heroes tonight. We will fly above the sky. We are heroes tonight. Show any fear. I've been flying from town
This is the game that you and me will be making together in this video, and I will walk you through the entire process of picking the art, to publishing it, and everything in between, split into multiple steps. Along the way, for our game. We can see that there are three functions: init game, game logic, and close game. So a game works like this. We have a window and we display stuff to it. Inside an if-init loop, we clear the screen and redraw it, taking into account the user's input. So, init game is called once in the beginning, and then game logic is called, let's say, 60 times a second, if the game runs at 60 frames per second. So this line here are just to clear the screen, and other small bits that need to happen. This line will tell the GPU to start computing everything that we have just given to it to draw, and it just has to be called once at the end. And this line renders a rectangle. Now we can start coding. If you ever get stuck coding a project because you feel overwhelmed, just start working at it, with the simplest thing that you think that could get you to the next step. It is useless to plan ahead too much if you don't know how to do that thing. So let's just start by drawing the spaceship. So we need to load the spaceship's texture first, and that is easy. We create
You're about to learn about OpenGL from Victor Gordon. He has created an excellent course for beginners, with simple to follow instructions and informative diagrams.
Welcome to this beginner course on OpenGL. If you're wondering what OpenGL is, well, it's a cross-platform graphics API that allows you to render 3D and 2D scenes with the power of your graphics card. Usually when programming, we use our CPUs, which are great at doing a huge variety of tasks one after another in a linear fashion. But when we deal with graphics, a lot of the tasks are very similar and don't usually depend on one another, so the fastest way to get a result would be by doing all of them at the same time in parallel. This is what GPUs, or graphics cards, excel at. OpenGL is simply a way for us to communicate communicate with the GPU. By the end of this course, you'll be able to import basic 3D models such as these into your application and have a firm grip on the basic concepts of computer graphics. Everything from basic buffers used to send data to the GPU to classic lighting algorithms and shaders. The only things you should be familiar with before we start are the basics of the C++ programming language and the basics of Visual Studio, since that's the IDE we'll be working with. The first thing you'll want to do is to check you have the latest drivers for your graphics card and the latest version of Visual Studio. Next, make sure you download the the 64-bit Windows installer for CMake and go ahead with the installation. Now download the source package for GLFW. Lastly, you need to download GLAD. Make sure you select C/C++, version 3.3, core, ignore everything else and press the generate button. Now press on the glad.zip to download it. Once you've finished installing CMake and Visual Studio, open up Visual Studio and click on Create New Project. Select Empty Project for C++, click Next, type in a name for your project, make sure the checkbox is checked, and remember in what folder you've placed your
I've heard great things about Raylib. I've been told it's one of the easiest game engine libraries to get started with, and all you really need is the library, this cheat sheet over here and maybe a quick look at the examples. So what I'm going to do today is set a small challenge for myself. I'm going to take this Scarfy over here and see how easy is it for me to create a simple program that allows me to control Scarfy to move him around on the screen. Let's get started. And let's start the clock. So the first thing I'm going to do is to take this example template and make a copy of it in my own directory. So let's go to Raylib Playground and we will call it 2D character. Now we don't need this big comment at the start telling us how to create an example. And we'll leave the rest as is. We want to get moving. So all going well, I push F6, I have a little script that will compile and run it for me. And I should get a window open up. Yeah, congrats, you created your first window. So let's close that. Yeah, thanks to Avast, I get two opens, but that's okay. So let's have a look at what we have. So the screen width and height is set up here. There's a simple initialization done. Set target FPS, we'll leave that as is. And then there's a simple loop. So while the window shouldn't close, that means nobody pushes the little X or the escape key, then we, in a loop, do this. So let's get rid of this congrats message. We're going to add our own drawing code to that. And let's change the title of the screen title to 2D character. 2D character animation. And there's little point in doing this, but if I compile and execute that, you'll see the changes. We'll have a completely empty window with our new title in it. So that's all good. Next, I'm going to need our little character, Scarfy. So under examples, he should be in the textures resources. There's Scarfy. So let's copy Scarfy over to our playground. Just dump him in there. And then let's head to our cheat sheet. How do we load a texture?
In this video, you will learn how to use the Raylib library by making a 2D and a 3D game. Raylib is a powerful module that has become super popular over the last few years because it makes it very easy to create more advanced games without having to rely on a game engine like Godot or Unity. It has a huge community and lots of available resources. If you just want to get into game development, Raylib would be an excellent choice. It shouldn't take you long to make something more advanced like Doom or Pokemon. For this tutorial, I will use Python, but Raylib is available for a lot of languages, and the tools are standardized, meaning with some modifications, you could probably follow along in another language. For the itinerary of this video, we will first cover all of the basics and 2D stuff. Then we make a 2D game, after that we cover 3D basics, and then we finish things with a 3D game. That way you learn how to organize your games, and you get dedicated recipes for things like movement and input, 3D models, cameras, animations, collisions, and so on. That being said, to make really good games, you want to have a strong math foundation, which goes beyond this tutorial. If you want to learn that though, check out the sponsor of this video, Brilliant. They offer interactive and incredibly well-made tutorials on a lot of subjects vital for game development. For example, in there, you get basic shape drawing functions. The simplest one is to draw one pixel, for which Raylib is expecting a position for X, a position for Y, and a color. Let's try that one. After we are clearing the background, I want to call draw pixel. And now I have to insert a position for X, Y, and a color. Let's set 100 pixels for X, 200 for Y, and for the color, let's choose something simple, red. If I now run the code, this is going to be quite hard to see, but if you look very closely, we have a red pixel here. I guess what we could also do is another function, draw circle. For this, we want to have 4 arguments, center X, center Y, radius, and color. Let's say I want to go 400 pixels on the X-axis, 200 pixels on Y. For the radius, I want to go with 10 pixels, and for the color, let's go with green. Now if I run all of this again, there you can see it much better. We now have a green circle a bit to the right of the red pixel we have just drawn. So those are the basic drawing functions inside of Raylib that allow you to draw basically any kind of shape. If you look at the entire list, you can find pretty much any kind of shape. The more complex the shape, the more arguments are expected. Should be fairly straightforward. That being said, there's one thing I want you to think about. If I run this again and move the window to the side, for this circle, we have set x to 400 and y to 200. How does this get us to this position here? Or in other words, what is our starting point? The way you want to think about it is that the window is a coordinate system. Our window at the moment is 1920 pixels wide. That is this dimension here, 1920. Besides that, the window is 1080 pixels tall. That is this side, 1080. And this will be our coordinate system in which we can draw. Really important for all of this, the origin point is in the top left. This will be position 0 and 0. This means to get to this point, we are moving 400 pixels to the right, or this distance here, and then we are moving 200 pixels down, which would be this distance here. With both of those, we're getting the center of the circle. This should be kind of familiar, because in high school, you probably worked with a coordinate system that looked something like this. You had an x-axis and a y-axis, with the origin point in the bottom left. In Raylib and most of game development, we have a similar system, except that the y-axis is inverted. If you want to go to the right, you want to increase x. And if you want to go up, for Raylib, you have to decrease y. Which does feel a bit counterintuitive, but for most game development frameworks, this is the default. And just to demonstrate all of this, this is our x position and this is our y position. If I set both of these values to 0, we should be in the top left. And we are. You can now see in the top left of the window, we have 1/4 of the green circle. I guess to make this a bit more visible, let's make this much larger. They can see the circle in the top left. And the larger x becomes, let's say 100, the further to the right we go, and the greater y becomes, the further down we go. If I make this number negative, we cannot see the circle anymore because it's now on top of the window, meaning the circle would be roughly here. If I change this to -50, we can see just a bit of it. So with that, you should be able to draw basically anywhere on the window, which means we can go a bit deeper into the drawing functions. Once again, here we have all of them, and what you see very often is that you have a basic drawing function and then variations of it. For example, we have draw pixel and then draw pixel v, which wants to have a vector for the position, or more specifically, a vector 2. Just in case they are new, let's talk about vectors for just a second. In the most basic sense, vectors are basically a list with a limited set of numbers. We have a vector 2, which has an x and a y value, and a vector 3, which has an x, y, and z value. These values are stored as floats, and you can both access and change them. To directly address them, you would do something like vector2.x, y, or z. In game development, vectors are a really easy way to store something like position or directions. On top of that, they also have lots of useful math functionalities. Because of that, you see them all the time. Which means, back inside of the code, besides draw pixel, we also have draw pixel v. This wants to have two arguments, a position, which has to be a vector 2, and a color. To create a vector 2 in Raylib, you simply want to type vector 2, and then you have to specify an x and a y value. I guess we can put this pixel right next to the original pixel that we have drawn. Which means for the position, I want to have 101 for x and 200 for y. After that, for the color, let's go with blue. If I now run this again, this is going to be very difficult to see. I guess we do need a bit more distance between the two. Let's go with 200 and 200 and make this pixel white. Then you can see this is quite difficult to make out, but there we have a white pixel, which we have positioned using a vector 2. And once again, to make this a bit more visible, you have a similar functionality for draw circle, meaning we can call draw circle, and if you're now at an underscore, you get quite a few different options. The one I want to go for is draw circle v, for which, once again, we want to have a center position that is now a vector 2, and then we need a radius and a color. For the position, once again, I want to create a vector 2 and place this one at 1000 and let's say 600. After that, we need a radius, let's go with 200, and finally, we need a color, something we haven't used yet, yellow. I can now run this again, and we're getting a big circle in the center-ish of the window. For this one, we're going 1000 pixels from the left, meaning this distance here, and we are going 600 pixels down, something like this, which is then giving us the new center of the circle. And alrighty, with that, we have basically all you need to know for the basic drawing functionalities. There's just one more thing that I do want to cover. Let's say I put these two circles in the same position, meaning they should both be on position 1000 and 600. What do you think is going to happen? Well, if I run this, we can only see the yellow circle, but we cannot see the green one. So what happened here? And if you think about it, I think you can see the problem. Raylib is drawing all of this in order, meaning we first draw this pixel, then we're drawing that pixel, then we are drawing the green circle, and finally we are drawing the yellow circle. Since those two circles are in the same position and the yellow circle is much larger than the green one, we are drawing the yellow circle on top of the green one. Or in other words, the green circle is behind the yellow one. If you flip those two lines around and draw the green one after the yellow one, then you can see both of them. Which basically means that you want to be really careful about the drawing order. This one is super important. If you call a function after another, then the later function will be drawn on top of the previous one. So with that, we have quite a few basics. Let's do an exercise. I want you to draw a line from position 0, 0 to 500 and 200. This line should be a really dark red color, which means you have to define a custom RGBA value. On top of that, the line thickness should be 10 pixels. Pause the video now and figure this one out on your own. To get started with this exercise, I would recommend to look at the documentation and then go once again to the drawing functions. This one contains a whole bunch of draw line functions. Since you want to define the width of the line, you want to look for something like a line thickness, which you do not have in draw line or draw line v. But you do have draw line x, which has a vector to starting position, a vector to end position, a thickness, and a color. Exactly what we need. Which means, back inside of the code, I want to draw line x, for which I want to have a start position, a vector 2, with 0 and 0. For the end position, I want to have a vector 2 that I believe was 500 and 200. Next up, we want to have a line thickness, which I want to set to 10. After that, finally, we will need a color, which I want to be really dark red, for which we need a tuple with a very low amount of red. Let's go with 50. Besides that, I want to have 0 for green, 0 for blue, and 255 for the alpha value. If I now run this again, we are getting a really dark red line that goes from 0 to 500 and 200. Cool, I hope that wasn't too difficult. If you could do the exercise, drawing basic shapes should be fairly straightforward at this point, which means we have custom shape drawing covered. Most of the time though, this is not what you want to do. For basically any game, you want to import and display images. And for that, if you look at the assets folder, there we have spaceship.png. This image I want to import and display. For that, first of all, we have to cover the import. This has to happen before we are doing the while loop, simply because we only have to import the graphic once. The function that you want to look for is called load_texture, for which Raylib is expecting a file path. And in my case, within VS Code, the starting point for the path is the root folder. From there, I want to go to assets. After that, we have spaceship.png. And really make sure that you are spelling all of this correctly. With that, we have a texture. This I want to store inside of another variable. Let's call it spaceship_texture. To draw it inside of the drawing bit, you simply have to call draw_texture, which first of all wants to have a texture, which in my case is spaceship texture. Then we need an integer for x and y. I guess for now, we can use 0 and 0 to have the ship in the top left. Finally, we have tint color, which most of the time you want to be white. I'll talk about this one a bit more in just a second. First of all though, if I run the code, you can see the ship in the top left. Now while doing all of this, there are two important things to understand. Number one, when we work with images, so any kind of PNG or JPEG file, we always have a rectangle. For the ship, it would look something like this. That's the actual size of the image, where we have visible pixels in the middle, that's the ship, and then we have invisible ones around it, which you can largely ignore, but they are there. Besides that, the other important thing is that when we place the texture, we always place the top left. This would be position 0 and 0. For the tint color, white is the default, and this one doesn't change the color at all. But if you use something like blue in here, then you're multiplying every single pixel with a custom color, which can sometimes be a nice effect, but most of the time, you want to have the graphics by themselves, for which you want to have a white tint color. And well, that's basically it. If you want to display an image, you want to load a texture and then draw the texture. For more information, you want to look at the documentation. For that, you have to go down quite a bit more. You have to go beyond shapes and go to R textures. In there, if you go a bit further down, you have texture drawing functions, where you have draw texture V, draw texture X, and so on. All of these draw a texture with some slight variations. Now before we continue, I want to cover some very minor import issues. Depending on the operating system, the path should either contain a forward or a backward slash. And you want to be flexible so your game runs everywhere. Or in other words, when we're loading the texture or the file path, I'm having a forward slash. I could change this to a backward slash and the game would still run fine, but this isn't a given. I want Python to dynamically create the proper path so we don't have to worry about it. It could, for example, happen that on macOS, you need to have a specific kind of slash, and if you don't have that one, the graphic will not be found. That would break your game pretty badly, and you want to avoid that. To fix that, we can use an inbuilt Python function, which you have to import first of all. You want from os.path import join. Join connects a couple of strings with the right slash. The way you would use it, and let me print the result. You want to call join, and then the nodes you want to go through. In my case, to get this kind of path, I want to go to assets, and then as the second argument, I want to get spaceship.png. If I now run this, we are printing assets spaceship.png with a backward slash, the same we have here. The difference now, though, is that this path is appropriate for the operating system, which basically means you simply want to get the join method and then use it to create the file path. The end result is going to be the same, and this issue most of the time is not going to be too important. Most operating systems are quite flexible, but in some rare cases, this could avoid your game from crashing, which is why you should probably generally include it. That covers the first issue. The second one is that depending on your code editor, you want to be really careful about the root folder. In VS Code, the path always starts at the root folder. But in something like Sublime Text, you are starting at the Python file. Or in other words, if I have the same code in Sublime Text and run it, we cannot see the ship. And on top of that, Raylib is giving us a warning that it cannot find the spaceship file. That is because for the path, Sublime is starting in this Python file, which in practice means you first want to go up one folder. In this section, we are going to learn about input. By the end of it, we can move a spaceship around using mouse or keyboard input. And input is one of the easier parts inside of Raylib. You can check keyboard, mouse, gamepad, or touch input, and for each of those, you have a couple of basic methods. That's pretty much it. This part shouldn't be too difficult. All you really have to do is go to the documentation, scroll down inside of the first bit, and somewhere you find input handling functions. There you get the keyboard, gamepads, mouse, and touch input. You can also check for gestures, but all of those get a bit more advanced. I'm going to focus on the keyboard and mouse input. I want to start with mouse input because this one is the simplest one. You could, for example, get the X or the Y position of the mouse, or you could get all of that inside of a vector too. You can also get the mouse delta, which is how much the mouse has moved since the last frame. Besides that, you can check if the mouse buttons have been pressed and if the mouse wheel has been moved. You can also set the mouse position, but that's rarely important. To learn about all of that, I have another Python file called free_input.py. This already contains a couple of basic things. We are doing the normal imports, we are initializing the window, and then we are getting the ship that we have seen in the last part. Although at the moment, this should be 0 and 0, so we don't have any ship direction. After that, we are clearing the background and drawing the ship. The end result is going to look like this. Not much happening at the moment. To fix that, before we are doing the drawing part, I want to check for input. Specifically, I want to look for mouse input. The methods here generally start with get, mouse, and then something something. For example, get mouse position, get mouse wheel move, get mouse X, Y, and so on. I suppose what we could start with is get mouse X. This method doesn't want to have any arguments, it simply returns the X position of the mouse. If I print it and show my mouse, the further I go to the right, the larger this number becomes. On the left side, this number is roughly 0 and 0, although if I go a bit further to the right, they can even become negative. And the more I go to the display width, we're getting very close to 1980, somewhere here. You get the idea. This can be useful, but usually it's not what you want, because a much more useful method for the mouse position is get mouse position. Don't forget to call this one. This will return a vector2, which means this we can use right away to overwrite the ship position. Or in other words, I want to get the ship underscore position and set this to wherever the mouse happens to be. With that, if I run this again, the top left of the ship is going to be wherever my mouse is, which is quite a nice effect. And that's basically it to get the mouse position. You can either get X, Y, or both. Other than that, you can check for mouse buttons being pressed. Those you can find under is_mouse, and then you have button down, button pressed, button released, and button up. And really quickly to understand the difference between them. You have button down and button up. Those check continuously if the mouse button is either held down or not held down. Besides that, you have button pressed and button released. Those are checking if the button has been pressed or has been released. In practice, the difference between them is that these are running continuously, whereas button pressed and button released are a one-time thing. I believe once I demonstrate all of this, it should become fairly straightforward. Let's start with a really simple one, is mouse button down. For this, we want to have one argument, which is the mouse button we want to check. 0 is the left mouse button, 1 is the right mouse button, and 2 is the middle mouse button. In my case, I want to check the left mouse button and then print the result. Like so. If I now run all of this, we get false by default, but if I click the left mouse button, this becomes true. If I release it, it goes back to false. That's really all that this one is doing. If you change this to a 1, then you're checking the right mouse button, and so on. This effectively gives you the state of the mouse button, which can be useful, but very often is quite problematic. For example, if you want to check if a mouse button has been pressed, for a specific button in the game, for example, you could do if and is mouse button pressed. Let's copy all of this with the left mouse button. If that is the case, I want to print mouse button rest. This is going to work, but it's not going to work well. If I comment out the earlier line and only check for this if statement, if I run the game now and I press the left mouse button once, we're getting mouse button pressed many, many times, even though I only pressed this button once. What happened here? This game at the moment runs at something like 4,000 frames per second, meaning we're checking this if statement 4,000 times per second. Even if I press the mouse button for a tenth of a second, this would still be hundreds of times of this while loop. And as a consequence, we are printing this statement multiple times, even though for me as a user, it looks like I only pressed this button once, which really is not ideal. The solution to that is instead of mouse button down, you want to check for mouse button pressed. This one fixes everything. If I run this now and I press the left mouse button, we're getting mouse button pressed only once. And this works multiple times. It's fairly straightforward. Mouse button up and mouse button released are basically the inverse of mouse button down and mouse button pressed. For example, if I add mouse button released, run all of this again, I can click with the left mouse button, nothing happens, but if I release it, we're getting mouse button pressed. That's really all that you're getting from these functions, which I think overall is all you need for mouse input. So next up, we can work on keyboard input. And while we're doing that, I want to comment out all of the mouse input so we're not getting confused. All of this should be commented out. For keyboard input inside of the documentation, you only have a couple of functions. Like for mouse input, you are separating between pressed and down. Meaning for is key down, you're checking continuously if a button is currently pressed or not. Whereas for key pressed, you're only checking this once. Like it says in the documentation, once and again here is super important. The only difficulty for this one is that you want to be aware what kind of key you are looking for. For which you have a whole bunch of constants, it's honestly not that difficult. Back inside of the code, I want to print the result of is key down, pressed, press, repeat, released, or up. For now, I want to go with is key down. As an argument, we want to have an integer, although this integer we're getting from a bunch of constants. The way you access them is if you press key, all in uppercase letters, then you get all of the options available. Simply look for what is available. Looks pretty good. Let's talk about collisions, which in the most basic sense are fairly simple. Basically what you do is check for collisions between a variety of shapes. If you look at the documentation, you have all of these methods. They always start with check collision, and then you can check, for example, for collision between circles or between rectangles or points and so on. I will demonstrate how that works in just a second. But first of all, a very important point is that you are just checking if a collision happened. You're not resolving this collision, meaning there's no position change if there is an overlap. For those proper collisions, you will need a bit more logic. I will cover that later. For now, I want to work inside of a new Python file called for_collisions.py. In there, we are doing the usual. We have a couple of imports, we are creating a window, and then we have the drawing loop. What we are drawing are a player and an obstacle, which are both circles at the moment. As you can see down here, we have draw circle V, for which we have a position and a radius. Besides that, we have a color. The player is white, the obstacle is red. Finally, the player position is going to be set by the mouse position, which we're doing here. The end result is going to be, if I run all of this, we have a white circle following the mouse, and then we have a red circle here. Between those two objects, I want to check the collision. For that, I want to add another section. Let's call it collision. And the end result, I want to print. For that, I want to check underscore collision. And then we have all of the options. The simplest one I think is check collision circles, which wants to have 4 arguments: the center and radius of the first circle, and then the center and radius of the second circle. In my case, I have the player underscore position and the player underscore radius. That's the first circle, and the second circle is going to be the obstacle position and the obstacle radius. If I now run all of this again, by default, we're getting false because there's no collision between the circles. Once they do collide, we're getting true. And that is pretty much it. Now I can check if there's a collision or not. Once again, for more detail, you want to look at the documentation, scroll down. The collisions are inside of the shapes part, down here. The method I've just used is check collision circles. But, well, none of those get that much more complicated. That being said, there's one new object that we have to learn about: rectangles. Rectangles in Raylib are a specific object, and shockingly, they are a rectangle, where you define the top left position via x and y, and then you set a width and a height. From that, you get a rectangular shape, which is surprisingly useful. The 2 most common functionalities are, number 1, you can use it for collision checks, and number 2, you can draw this rectangle. And by drawing, I mean you could either draw the rectangle itself, or you could draw a specific area of a texture, whatever you define via the rectangle. In our case, I want to create, let's call it R1. This we create via rectangle, and then we want to have a position and a size. For now, I want to have 0 and 0 for x and y, meaning we are on the top left, and then at 100 and 200. This rectangle will be 100 pixels wide and 200 pixels tall. To see it, we have to draw the entire thing, and that we do inside of drawing. I want to have draw rectangle, and then you want to have draw rectangle rec. That way we are using a rectangle object for the actual drawing. If you simply use draw rectangle, Raylib wants to have position x, y, width, and height as separate integers, which I don't care about. I want to have draw rectangle rec, in which I add R1 for the rectangle, and then a color. Let's go with blue. And now, in the top left, we have a rectangle that at the moment doesn't do very much. That's totally fine though. What we could be doing at this point is comment out the current collision check, and then print another collision check. I want to check work with. A really important part of any video game is a camera. That way you can explore a level and see the actual world. Implementing all of that in Raylib is quite easy, since you have dedicated camera functionalities. This also allows you to rotate and zoom, and is ultimately fairly powerful. And to explore the camera, I have a new Python file called 5camera.py. In there, we are already doing quite a few things. Let's go over it really quickly. We are importing Raylib, and then we are using the random module to get rand int and choice. Those we are using down here to create a whole bunch of random circles. I'll talk about this in just a second. First of all though, we are creating a basic window, and we're setting up some attributes for the player. I think one part I haven't talked about yet is that if you create a vector2 without any arguments, you're getting 0 and 0. This player is going to move around on the screen. For that, we have the usual stuff. We are getting player input and normalize the vector. After that, we are using that information to move the player around. All of that gets drawn down here. That way, for the player, we're getting a black circle. That's the part that should be super easy. Besides that, we are doing all of this. What's happening here? This is a list comprehension in which we are creating this tuple for I in range 100, meaning we are creating 100 tuples. For each tuple, we're getting 3 bits of information, a vector 2 for the position, and for x and y, we're getting random values that are between -2000 and 2000 for x, and -1000 and +1000 for y. Next up, we have a random integer that is also a random value between 50 and 200, and finally, we are picking one of these colors. By the end of it, we are going to get a list with 100 tuples where each tuple contains these 3 bits of information. All of that, we are using a bit further down on these 2 lines, where we go through every single circle, and then we are calling draw circle v, where we are unpacking the circle, which is going to give us the vector 2 for the position, the random integer for the radius, and then the color for the, well, color. The end result is going to look like this, where we have a whole bunch of circles and the player can move around. That is looking okay, but now we have a problem. The circles extend for quite a while. For example, we have a whole bunch of random circles here, 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 and I think you get the idea. Outside of this screen, we have a whole bunch of circles that we cannot see yet. To see those, we need a camera system. This consists of 2 parts. Number 1, we have to create a camera itself. This I want to store in a camera variable. To create it, you want to type camera 2D. No need for any arguments. After you have that, when you are drawing everything inside of this part, you have to add begin mode 2D, and as an argument, you add the camera that we have just created. So camera in there. Also, after you finish drawing the camera part, you want to end mode 2D. Although this one doesn't need any arguments. If you're doing that, all of this stuff will be relative to the camera. Although if you're running this now, nothing is going to happen. So this is not ideal yet. The issue we have at the moment is that this camera needs just a bit more setup. The most important part for now is that we need to set the camera zoom, which by default is 0, which is going to break everything. A much better value for this one would be 1, which is going to get you back to the default view. So this is feeling much better. At least we can see something. but the camera still doesn't do anything. That is because the camera needs a target, which should be a vector 2. Specifically, we should get the player position, which means I want to have the position of the player in there, and now this still doesn't do anything. That is because this target needs to be updated continuously, which happens inside of the while loop. I want to add another section for the camera update. In there, I basically want to copy this line. Camera target is the position. If I now run out of this again, I can move around, and we're moving the entire screen. Although the player is always in the top left. That's not ideal yet, but at least we're making progress. To get the player in the center of the screen, you want to give the camera an offset. The value should be a vector 2, and then we need an x and a y value. By default, we're getting 0 and 0, which puts the player in the top left. But if I change this to, for example, 500, run this again, now we're moving the camera 500 pixels to the left effectively. We can do the same thing on the y-axis. If I set this to, let's say, 1000, then we have moved up the camera relative to the player by quite a few pixels. And to get the player right in the middle, you want to get the window dimensions, which in my case are 1920 by 1080. I want to get half of that, meaning 1920 divided by 2 and 1080. Divided by 2. And let me add a bit of white space so it looks better. If I now run this again, we have the player right in the middle, and we can move around and explore the level, which looks really nice. That would be the most basic camera setup, where you want to get a camera setup and then update this camera. On top of that, you have to include begin mode 2D with the camera and then end mode 2D. Anything that is not between these two lines will not be affected by the camera. So just keep that in mind. What you can also do with the camera is set a rotation and a zoom level. If I set camera.rotation, for example, to 20, then, well, this is quite hard to see. But if I now simply move up, we are moving at an angle. If I make this a bit stronger, let's say 45, run this again, I am only going to move the player up. I'm pressing nothing else besides the up button. But if I move in this way, we are moving at an angle. That is because we have rotated the camera, which is very hard to see if you only have circles. Maybe not ideal, but if we update this in real time, it's going to be visible. For that, the default camera rotation should be 0, and this we want to update inside of the game. For that, first of all, we will need, let's call it a rotate direction. This is going to work similar to what we have done with the movement input. In fact, let me copy it. I just need different keys. Let's say for this one, I want to get key S minus key A. Then we are checking the S and the A key on the keyboard. And those I want to use to update camera.rotation. I simply want to add plus equal rotate direction multiplied with delta time and multiplied with some other value, let's say 50. So the rotation isn't too slow. If I now run out of this again and I press S and A, we are rotating the entire world, which can be slightly nauseating, so I hope it's not too confusing. And to zoom the camera, you could use a similar system, although that part is going to be your exercise. I want you to zoom in and out using the Q and W key on the keyboard. You could use any other key, it doesn't really matter. I just want you to have some kind of functionality so you can zoom in and out. Also a system so the camera doesn't break if you zoom out too much. You'll see what I mean if you experiment just a bit. Anyway, pause the video now and see how far you get. We have already seen that camera zoom is the, well, zoom. This we want to control, for which we first of all need, let's call it a zoom direction. For that, I want to once again copy what we have done up here, and then change this to key W and key Q. Once we have that, I simply want to get camera.zoom and add the zoom direction multiplied with delta time, and then I multiply all of this with 2, so it's a bit snappier. If I now run all of this, I can zoom in and out, I can zoom in quite a bit, and I can zoom out a lot as well. Although if you zoom out too far, let me try to get it, then we are inverting the entire thing. Right now I'm pressing up, but the player's moving down. That is because the camera got really confused. If I zoom out once again, the camera works just as intended. If these values become too large, you are going to get some really weird behavior. To fix that, you want to get camera zoom once again, and then assign a limiter to it, which you do by first assigning a max value, meaning we are picking the larger of two values. I want to go with 0.2, and then the camera dot zoom. If I now run this again and I zoom out, then we can never go beyond this point. We can still go back, but this is pretty much what we need. And by the way, the issue we had earlier with the camera inverted is where we reached a value below 0. If you want to have another limiter, you could add min here and then set something like, let's say 5. That way, we can only zoom in up to a certain level, meaning if I run this again and I zoom in, we are stopping somewhere here. Let's go with something smaller. Let's go with 2. And now I can zoom in only up to this point. And I can still zoom out quite a bit, but this feels a bit nicer. For this system, simply play around and see what looks best for your game. There isn't really a universal answer. The last major part for the absolute basics of Raylib is going to be music. So we can play audio files. For that, if you look at the documentation, you can go down for quite a bit. At some point, you will find R audio. This gives you all of the methods that you're ever going to need. The really important stuff here is, first of all, you have to set up the audio device. It can be a bit annoying, but you have to deliberately activate audio playback. After that, you can load and play a sound file, and load and play a music or an audio stream file. And that's pretty much it. Which I think already begs the question, what's the difference between sound and music? Sound files are stored in the RAM and should only be used for effects. That way we don't clutter up the RAM too much. Music, on the other hand, is streamed from your hard drive, which makes them a bit easier to work with from the resource perspective, so especially for background music and longer tracks, this is what you want to do. And that's basically all you have to do for the differences. If you want to have effects, you want to have audio files. If you want to have background music, you want, well, music. Inside of VS Code, I'm working inside of 6_audio.py. Besides that, if you look at assets, we have laser and music.wav. Those are the two files I want to work with. Although, first of all, for that, we have to set up audio playback, which in practice means below init window, you want to init an audio device. Don't forget to call this one. After you have that, you can play audio files. Although what you also want to do after you've finished the game You want to close the audio device. Once you have all of that, you can load and play an audio file. For example, in my case, I want to have a laser sound, which we're getting via load_sound with a path that we're getting from join. I want to go to assets, and in there we have laser.wav. To play this file, all we have to do is play_sound with the laser sound. If I now run the code, we're getting a laser sound. Besides that, if you want to play music, you want to load a music stream. For which, once again, you will need a file path. I want to get to assets, and in there we have music.wav, this file. To play that, we will need a couple of things. First of all, we have to call play music stream with the audio file we have imported. For that, I want to create a music variable and paste that one in there, music. If I run this now, we're getting the laser, but not the music. For that, we have to update this music stream, which happens inside of the while loop. You want to call update music stream with the music file, the one we have imported. Finally, at the end, you want to unload this music file as well, which you're doing with unload music stream. And once again, the music file you have imported. Once you have that, you are getting music. And that is pretty much it for audio. You can either play a single sound effect. For that, you want to have a sound file, or you can play background music that is streamed directly from the hard drive, for which you want to have a music stream. Which means we are done for this part. Music is usually quite easy. At this point, we have all the basics of Raylib, at least for 2D, meaning we can create pretty much any two-dimensional game. That being said, to create complex games, you want to have one more really important ingredient, and that is organization. If you want to create more complex games, you want to use classes. That makes it much easier to manage larger projects. Especially for a game with multiple entities, for example, a player and a couple of lasers, this becomes incredibly important. So let's talk about it. When we're talking about classes, we basically talk about that we want to use object-oriented programming to organize our game. For example, a spaceship class might contain the texture, position, and movement for that spaceship. On top of that, via inheritance, the entire system can become even more powerful. For all of that, I have a new Python file called 7classes.py, which at the moment really doesn't do very much. We have basically the minimal setup for Raylib. If I run all of this, we're getting a black screen, which is totally fine. On this screen, I want to move the player around, and for that, I want to create a class called player. In there, I want to call a unedited method, which will need self and let's say a starting position. This we then want to store inside of the class, so self.position is going to be the position. On top of that, I want to get self.texture, which we have to import, which happens via load_texture, and then via the join method, I want to go to assets, and then get, I think it was called spaceship.png. We want to go to assets, and in there we have spaceship.png, the file we have already seen. Simply with that, we can already create one instance of the player. So player is going to be player in one position. Let's say 500 and 200. This should be a tuple as well. To draw all of this, I have to call draw texture v, where we get player.texture and player.position. The tint color, as always, is going to be white, and now we have the ship somewhere on the window. This works really well. And very importantly now, we have all the player attributes in one place, in the class, which makes it much more organized. And this is just a start. This system can become even more powerful. For example, what we could be doing is organize the drawing of the player inside of the class itself. I guess we could call this the draw method, which will always need self. But other than that, we simply want to call draw texture v, the line we have already covered down here, and add it in there. The only change we have to make is instead of player, we want to have self. That way, we can simply call player.draw, and we're getting the same result, which does feel a lot more elegant. Now we have all of the logic contained inside of the player. Another nice thing that we could be doing for this is define an update method that we call continuously. In there, for example, we could move the player, for which I want to go back to input and copy all of this stuff. Place it in here, and then we have to make a few minor updates. First of all, we want to get a direction for the ship, which we define inside of the init method, self.direction is going to be a vector2. This self.direction, we are then updating inside of the update method, so instead of ship direction, we want to have self.direction. After that, I want to update the position of the ship, or in other words, I want to update self.position. The direction is going to be self.direction, and then we need self.speed as well, which doesn't exist yet, but it's super easy to get. Self.speed is going to be, let's say, 400. With that, we are updating the position of the ship, and then draw the entire thing down here. As a consequence, all we have to do inside of the game loop is simply call player.update, and then we are getting an error. And that is because self.position.x doesn't exist. That happened because the position at the moment is a tuple, not a vector2. This should be a vector2 with that starting position. Now it should be working, and we can move the player around just fine. This is really nice. And well, with that, we have a fairly powerful player class that we can minimize and then not worry about it again. Inside of the actual game logic, this is barely visible. Meaning, if you have multiple classes and lots of stuff going on, this kind of system makes your game much more manageable, which is why it's something you basically always want to do. To practice all of that, I want you to create a block class that slowly moves to the right. Also, while creating this class, you should be able to set the speed and the position of this block. And by position, I mean starting position. The other things like color and size, you can set on your own. It doesn't really matter. Pause the video now and see how far you get. I want to create another class called